Look, I totally fixed my green screen. Anyway, let's do some homework problems. We're going to start with number 8 on the homework. Pick the graph of the following function. Okay, what do we know about this function? We know a lot of things. I'm going to start by looking at the multiplicities. Or maybe I look at our options. All of these look like cubics. All these have the same end behavior, the same long run behavior. They have different intercepts. So we can look at the intercepts, probably the best. Okay. So this has an intercept of -1 and -2. Can't be this first graph. Maybe it's a second graph. Maybe it's this third graph. Can't be this one. Intercepts are -1 and -2. So it's either this second or this third. Remember, you can zoom in if you want by pressing the magnifying glass. All right, let's look at multiplicities. The -1 should have multiplicity 2. What does multiplicity 2 mean? It means at -1, we should be bouncing off. -2 has multiplicity 1, -2, we should just go straight through. So this looks believable. Number 2, check out number 3. Oh, this one switched for the multiplicities, isn't it? In this graph, -1 is multiplicity 1, so it can't be the third one. Got to be the second one. There we go. So check all the same things that we check in the notes. Degree, multiplicities, intercepts, all of that stuff. That's how you can do these sorts of problems. Look at 10 next. And then, Jason, why'd you got to put something with so many words? I found this problem specifically for you guys. I like this problem. So let's get going. When you have something caught in your throat, your sympathetic system goes into effect and forces you to start coughing. That's nice. So we can dislodge the foreign object from your windpipe. For me, it happens very often when I try to breathe saliva. Would not recommend. So the velocity v of the stream of air used to dislodge the object from your throat is related to the normal radius, capital R, of your windpipe in millimeters, and the restricted radius, little r, of your windpipe, also in millimeters during the cough. Okay, so that makes sense, right? How fast you cough depends on how big is your windpipe normally and how big is your windpipe when you're coughing. It's going to constrict, right? All right, sure. So the radius of your little guy, your constricted windpipe, has to be between, well, it's not going to, your windpipe's not going to expand, and it's never going to get smaller than half of your normal windpipe. All right. And K depends on the length of your trachea. Okay, that's something related to your throat. So in our specific case, our K value is 2.8. And our normal windpipe radius is 10 millimeters. So graph this function. It's got a lot of letters, but the problem told us what our letters are. So let's just do that right now. Let's graph this function. The velocity function, v of r, is equal to k, which is 2.8, times big R, which is 10, minus little r, which is our variable, times little r squared. That's all there is to it. Okay. And we want to find the width of the windpipe for which the velocity is a maximum. Velocity is the function, right? This is our velocity function. When are we the biggest velocity function? So again, we do the same thing where, oh man, we zoom out. Oh gosh. So we zoom out until we can see the top, but now the X's are way too big. So let's just go to the graph settings and let's make the X's smaller. They're really our values, our inputs. We're never going to have a windpipe radius of 0, hopefully. All right, what's the biggest windpipe radius? The biggest windpipe radius is our regular windpipe radius, that capital R, it's 10. And we can say, oh, okay. So this makes sense. If Like we wouldn't be coughing if we weren't restricted. You can't cough without restricting your windpipe. The velocity would be 0 there. And if the size of our windpipe was 0, yeah, nothing's going to get through. The velocity would be 0 there too. Velocity is biggest when we're about 2/3. I think this is scientifically accurate. You can Google it. We cough at about like 2/3 restriction. All right. And the velocity would be 414 point something units per unit. What is that? Millimeters per second or something? We're missing we're missing information. Anyway, the maximum value occurs when our input is how many? It says 2 decimal places. Input of 6.67 millimeters. There we go. I love that problem. Hope you don't hate it. And if you do, hope this video helps. What's the least possible degree? Well, you can look at turning points. You can look at zeros. There's 1 0 here, 1 0 here, 1 0 here, 1 0 here, 1 0 here. 5 zeros. Each looks like it has multiplicity 1. So maybe it's degree 5. What about turning points? 1 turning point, 2 turning point, 3 turning point, 4 turning points. Okay, the degree has to be at least 1 more than that. So it has to be at least 5. Is our end behavior right for an odd polynomial? Yeah. Odd polynomials have opposite. Okay, my shirt's kind of see-through. That doesn't work. Yeah. I think it's going to be 5. Should be odd, and it has to be at least 5. There it is. All right, let me know if you have any more questions. Have a good rest of your day. Hope this helped. Bye-bye.